Hi everyone, this is some guidance on last week's report. That would be the week 6 reports. There was 3 scenarios and you had to test whether there was a significant difference between the 2 variables. First thing to bear in mind when you're doing these comparisons between means is whether you've got any additional information that can help you decide the direction of the effect that you're interested in, and this is a situation where we would want to choose one or two-tailed tests, this one here, okay? And also, depending on our design, whether people are repeating a task in 2 different situations, then we are able to pair the responses together. So we've got 2 measures for each person, and this is a slightly different test procedure, and so we have to choose between whether we've got paired samples or not. Okay. So those are the 2 decisions you can make up front. You should only use a one-tailed test if you've got genuine reasons to suspect that the sign of an effect would be in a particular direction. So, you're going to apply fertilizer to a field. You want the plants to grow more than they would normally do, so you're only interested in increases in yield of some kind. So you know in advance that that's what you're looking for, and everything else is not interesting. Of course, with a one-tailed test, then the sign of the test will be different depending on the order that you make the comparisons in. So in the first scenario, the placebo actually gave a larger discomfort value than the drug, okay? And if we have the drug results in the first column and the placebo results in the second column, then the test will take this as the first variable and this is the second variable, subtract the 2 of them, and you get a difference in the means of minus 0.07, so the t value will be negative, okay? So we're testing for, in this case, a situation where the mean is expected to be less than the hypothesized null value, which is 0. That's no effect, okay? The other thing that we did in the class was come up with something to do with effect sizes. Cohen's d is one of the choices we can make in this situation, and all of these different types of effect sizes take some measure of a change, a difference in the means, and compare that to the average variability in the sample, in this case the standard deviation. If you've got 2 samples, you can combine them in different ways. You can take the largest one, which is a conservative estimate. You can take the control group as being maybe more representative, or you can take the average if you think that the variances ought to be about the same. Okay. And given that you might find that the p-value is not significant, doesn't exceed your type 1 criterion threshold, okay, it's greater than 0.05, do I proceed to report moderate or large effect sizes? Well, potentially you could do. I mean, you may be finding what could potentially be a large difference. The upper limit of your confidence interval or something might indicate. So this would be a case for proceeding to do more data collection. The p-value depends on the size of the effect. Okay, if you're getting big differences, they're unlikely to occur by chance, so the p-value is small. And also, in the case of a t-test, the size of the sample. Remember that the t-value is the difference in the means divided by the standard error, and the standard error decreases with the square root of the size of the sample. And actually, you can always get a significant result, because there are always slight differences between the different populations you're measuring, okay, which might be differences caused by things you're not interested in, and if you get large enough samples, you'll always get a significant p-value. Okay, so the p-value doesn't really tell you an awful lot at the end of the day. The effect size is much more important. And there's a paper you can maybe read here. It's the effect size stupid, he says, what effect size and why it's important, which you could download and have a read of. And confidence intervals is a way of sort of combining these two things. What it's trying to give you is more information about the range that you could expect to find the real effect within. Okay, so you're estimating the effect, which is the difference in the means. Okay, the increase compared with the drug compared to the control or whatever. And the confidence interval gives you a range of values. Okay, which on 95% of occasions, for example, would encompass the true mean of the difference in the populations. If the confidence interval includes 0, then that corresponds to the case where the p-value is greater than your criterion level, so greater than, for example, 0.05. And here's one of the tables that's produced by the software here, and there's a confidence interval range here for a two-tailed test. Okay, this would show that the lowest score of the difference that you might expect to find is still less than 0, but it doesn't encompass 0, but it could be as low as below -1. Okay, so there's a range in this case from -1/4 to -1.3, which is it's got a p-value of 0.003 associated with it. Okay. You don't subtract the upper and the lower confidence limits to find a different value. Okay, the sort of width of the range. What's important are the boundaries that are set on the range, and it gives us some idea about how uncertain we are about the differences in the means. Obviously, the wider this gets, and the more uncertain we are about what the actual value of the difference is. One-tailed tests, that's a little bit more confusing. This statement here, some students say, the significant difference for the confidence level as the confidence intervals do not include 0. That's true, okay, for both one-tailed and two-tailed tests, but you've got to bear in mind that for a one-tailed test you're only interested in sort of one end of the limit. You've decided in advance that the mean value you're expecting is going to be greater than 0. You're increasing the yield in your crop to increase, or whatever it is, and so it's only where the lower limit is placed that's of interest. I've lost me. There it is. There's my pointer. Because when the lower limit exceeds 0, then you know that you're not expecting the true mean to be less than 0. Okay, and conversely, if you're expecting the sign to be the other way around and you're going to test for differences below 0, you're interested in the position of the upper confidence level. How great could it be? Well, as long as that confidence level is less than 0, then we would expect the population mean on average to be below 0. Okay, so that's slightly sort of tortuous kind of thinking around these things. Here's a difference in two means for a one-sided test against the criterion that mean 1 is greater than mean 2. Here we can see it's got a positive value, okay, with a particular t statistic, a low p-value, and the lower confidence interval you see is greater than 0. So this is saying that 95% of the time, if we would expect our true mean that would be in the region of 0.026 and above. Okay, that's in that region there. Okay, so that's all we need to do for this week on that, and I'll talk a little bit about the peer review aspect next.